Draw a truth table for the following Boolean expression. And the following, the Boolean expression that we are going uh, to write the truth table is this one. We have a y is equals to a not b c d, or not a b c d, or a b overall bar c d, or a b c overall bar d. So the first thing here what you have to know, you have to identify the number of inputs. Here we have 4 inputs. So after identifying the number of inputs, you determine the number of rows the truth table will have. Number of rows is calculated by formula 2 power n, where n is the number of inputs. So in this case, the number of rows will be 2 power 4, which is 16. So we shall draw a truth table of 16 rows. So let's have here, we shall have our equation again. Y is equals to a b c d plus not a b c d plus a b overall bar c d plus a b c overall bar here d. So here we are going to have 16 rows. So in the first case, now let's draw first the inputs a b c d, a b c d. So let's have this. So let's make our table. So we have that table. It may seem like a simple question, but it's very tricky if you are not careful, because this one has was rated at 5 marks. So for the inputs now, we can indicate, we start from A, so we shall alternate. We get 8 zeros, 8 ones, we reduce like that up to D. So let's have it here. We have 8 zeros, 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Then after that we go with 4 zeros, 4 ones. 1 2 3 4. 1 2 3 4. Is it? Let's have let me undo. You have these are 8, so this is not 8. Let me have it again. Let me have it again. Let me have it again. So we are going to have 8 zeros. That is 1 2 3 4 5 6 7 8. Then we have 8 ones. 1 2 3 4 5 6 7 8. Then we go with the 4 zeros, 4 ones. 1 2 3 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. We go with 2. We go with 2 2. So we go with 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Then we go with 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1. That is for the inputs. That comes automatically. Then we are going now to the next steps. Let's go to the next steps. So in this expression, we have some terms that have been negated. Others have an overall negation. For example, this one has an overall negation. This one. Also this BC has overall negation. So it is good to have to break the expressions in portions. For example, if we have somewhere where we have B negated, we have a column for it. If we have somewhere we have A negated, we have a column for it. Then as you negate, you consider the inputs. So if it is B, where there is a 1, we put in B negation, we put 0. If there is 0, you put 1. And also you consider for every other term. So in this case now, let's start. I'll make a column of B when it is negated. I will make another column of A when it is negated. Also, you can see there is AB overall negation. I'll make that column. You can see there is so the major terms that we have to make extra columns for are those ones. We have for B, for A. Then another one is for BC. So let me have these rows. So I will have that. So now in this case now, I am going now to negate the input B to get B negated. So where there is 0 for B, we put a 1. So for B, here we shall have 1 1 1 1 because of these 4 zeros. Then we go with 4 zeros, 0 0 0 0. Then we are considering the row of the column for B, negating it. We go with the 1 1 1 1, then 0 0 0 0. Then we negate B, we negate A, so we shall start with the 9 ones because we are negating these zeros. So we shall have 1 1 1 1 1 1. These are 4. Sorry. We have that. So for this column of A, I will have 8 ones. So we have 1 1 2 3 4 5 6 7 8. Then we have 8 zeros. 1 2 3 4 5 6 7 8. So we have negated A, the input of A. Let's go now to AB overall negation. AB overall negation. Remember, we are going to perform AB, that is a multiplication. Then after that, the result we negate. So in this case now, we shall have, what we are going to do is, we take the input of A. For example, here we have 0, 0 and 0. We normally get a 0. Then we negate that 0 to get AB negated, which will be 1 here. We go like that. For example, now in the case where we have 1, 1, we have 1 and 1. We normally get a 1. We negate 1, we get a 0 here. So that is what we are going now to do. So when you do that, you shall get at the bottom here is where you shall get only 4 zeros, and the rest will be ones. So since I have explained how you get it, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have the rest will be ones. 1, 2. So let me count whether it is 16 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. So that is how we do that. Then also for this BC, we take the input B, we multiply with C, and we negate. So 0 and 0 we get 1. We negate, we get 0 and 0 we get 0. We negate, we get 1. So we shall write 1. If it is 1 and a 1, or 1 and 0, we normally get a 0. We negate, we get 1. So when you do that, for BC will get, we shall start with, we shall have, you realize that we have the first rows will be 6 ones. 1, 2, 3, 4, 5, 6. Then we go, we get 0 here, 0. We get other 6 ones. 1, 2, 3, 4, 5, 6. And we finish with the 2 zeros. The rows may not coincide with one another, but you have to follow what how I have guided. So for example, let me check. Here we have 1. So why do we have 1 here? Because I took input of B 1 and C is 0. So 1 and 0 we get 0. We invert 0, we get 1 because of this negation. Now after that, now I will have now the terms as they are in the expression. So I write my 4 terms as they are in the expression. So I will have here A, I will have B negated, C, D, I will have A negated, B, C, D, I will have A, B overall negation, C, D, I will have A, I will have B, C overall negation, D. So let me draw this. Then remember, the very last column is the output Y. the very last column should be the output y, whereby now these four terms of ours will be added together, where now we apply the OR operation. So let's start. So we are going to have, we are going now to use these particular extra columns we have made. So we are going to take the initial A here. For example, in this, we are going to take the initial term A. We use BC that we have already constructed and D. So for example, and you know this is multiplication. So for example, A is 0, BC is 1, and D is 0. So when you multiply that, as long as all the constant terms are not 1, then we get a 0. So you will use that method, and when you use that method, you will find that you will have you will have only one row having 1 in this column. So we shall have zeros, or we shall have how many zeros? We shall have 1, 2, 3, 4. We shall have 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then we have 9, 10, 11. Then we have a 1. Then we finish up with 4 zeros. So we realize that this row, that is this 16th row, 15th row, 14th row, 13th row, 12th row. The 12th row is the one that will have a 1. Meaning all the inputs will be 1. A, BC is also 1, and then D in this case is also 1. So 1 and 1 and 1, we get a 1. Let's go to the other term. We are going to use here, we are going to use negation A. Because of this, we use the initial BCD. And when you do that, you will get this we will realize that from the first row we shall have 7 zeros. 1, 2, 3, 4, 5, 6, 7. Then after that we have a 1. Then after that we finish up with zeros. So this 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we shall have such kind of a column. Then we go to the other term. In the other term, you use this extra column you have constructed, then C, the initial CD, and you multiply the whatever values are in those columns. So when you do that, you will find that you will have this column. Start with 3 zeros first. Zeros, we'll get 3 zeros at first place. We have a 1. After that we have 3 zeros. We have a 1. After that we shall have 3 zeros. We have 1. We have 3 zeros, 1. After that we shall have other 3 zeros. Then a 1. Then 4 zeros. The rows may not coincide, but when you follow the how I am doing it, you'll get the correct values. So when we go to now the other one, we shall use the column that we constructed for BC overall negation and the initial A and D. Then you multiply them. So using the logical multiplication. And when you do that, you'll find that you'll have you'll have 3 zeros, other 3 zeros, other 3 zeros, a 1, then 0 1, then we finish up with, we have another 0 1, then we have 2 zeros at the end, 2 zeros at the end. Then for the output y, now what you do here, as you can see, now we have constructed for the terms, for each term that we have in the equation. So what you do, because the terms have been added, you use the OR operation, which says if either is 1, we get a 1. So where all these terms have a 0, we get a 0 at y. And if either has 1, for example, in this case, here we have 1, then we get an output of 1 at this end. So when you follow that way, you will have 3 zeros, you will have a 1 because of this, we'll have a 1, we'll have other 3 zeros, you will have 1. If you be using a book that has got some lines which are well drawn, then you will get a good table. So we have that, we have 1, we have 0 1, we have 0 1, we have 0 1, then we have another 0 1, and we have 0 0 at the end. So we have, let me confirm, we have 3 zeros, we have 1, we have 3 zeros, we have 1, we have 0 1, we have 0 1, 0 1, and 0 0. So that is how you go about that kind of an equation. So with the 5 marks for a truth table, there should be a concept that is being tested in the question. So that is how easily you can break up an equation and get the final truth table. But if you are smart enough, then you can have the inputs and you compute each term directly to this point. But I advise that you break, if there are some terms that have been negated, construct extra columns for them, then join them to get the terms, then get the terms, do the operations that have been done in the main terms, and get the correct output at the end.